In lesson 3, we're going to take a look at multiplying and dividing radicals. All right, so just like we did in the last lessons, we're going to just start out by looking at some notation. So it looks complicated with all the letters happening there, but what this is really saying is if you had some radical, right, so some number, m, times, and then the r there just means it could be any index, right? It could be like a square root, cube root, fourth root, anything else. And then you've got your radicand underneath. So if you multiply that by some other radical, then you just really multiply the coefficients out front, so m times n, and then you multiply the radicands underneath, so a times b. But it has to be the case that the index is the same. Okay, so no worries if that seems a little bit confusing. I think let's just jump into some. These steps are handy to kind of remind you how to do these after. But I think if we just jump into it, it'll make sense to us. So for the first one here, we just have 5 root 2 times 7 root 3. So they both have the same index. So all we have to do is just multiply the coefficients. So this is just 35, right? 5 times 7. And then times. And then it's just 2 times 3. So this is going to be root 6. And that's it. Not too bad, right? So that one's usually pretty straightforward for students. All right, so for B, we now just have 3 different radicals happening. And again, we'll just remember for our coefficients, if there's nothing there, there really is a 1 sitting out front. So doing the coefficients is pretty easy to begin with. You got 1 times 2 times 1. So it's going to be 2. Oop, that was weird. 2. And then root. And then we just got to figure out what the radicand is now. You would want to, like if you can, it'd probably be nicer to simplify, right? Like to take out as much as we can under the square root. But there's not a perfect square that goes into any of those, right? Like 4 doesn't go into 15 or 9 or 21, right? So we're kind of stuck with just multiplying those 3 together. All right, so at this point, probably grab your calculator. And it's 5 times 15 times 21. So we get 1,575. So that is right, like that is all those radicals multiplied together. But we remember from the last lesson that we always want to simplify at the end if we can, right? We want to take out as much as we can. I can see right now that this ends in 75, right? So I know that 25 goes into this. So why don't we divide by 25 and see where we're at? And sorry, yeah, the reason that we're dividing by 25 is because 25 is a perfect square, right? So we're looking for like that 36, 49, the perfect squares that we know. So let's go that number. So I'm just going to push divide because it stored the answer from above. So divide by 25. So 63. So I'm going to rewrite this as 2 root 25 times 63. So now I have this as a perfect square times some other number. So this 25 gets to come out, right? It gets to come out as a 5. But when it comes out, it's gonna be multiplied with a 2 that's already out there. So this now becomes 10 root 63. And just being careful looking at this, just wondering, okay, is there a perfect square that goes into 63? And yeah, there is, right? We can divide that by 9, which is a perfect square. Oop. Oop. Okay, so this will be 10, and then root 9 times 7. And then we don't need to leave that 9 in there. We get to take that out because we know the square root of 9 is 3. So this is going to be 3 times the 10 that's already out there. This is 30 root 7. There you go. Okay, let's look at C. Okay, so for this one, we've done these sorts of things in previous years, pretty much. You might recognize this a bit more as something like maybe this, like if we had, let's say, 2 times x plus 4, right? When we were doing that more with algebra. And maybe you remember this distributive property, or like a rainbow, right? That we want to distribute that in. We're going to just do the same thing with radicals now. So we're going to distribute this in. It's got to be multiplied by both those terms. All right, so now this is root 3 times 5. nothing we can really do though. Those are different things, right? Like, I can't like multiply the 5 by the 3 because this one's under the square root and this one's not. So all we can do there is just rewrite it as 5 root 3. And that's it. It could be root 3 5 too, but typically we write the coefficient and then the radical. So then looking at the next one, you got root 3 times root 2. So that is positive, because it's another term, root 6. 3 times 2. Now you would try to see at that point, can we collect our like terms, or are there like terms? And there's not, right? Root 3 and root 6 aren't like terms. So we just leave our answer just like that. Okay, so now we just have another one. So this is negative 2 root 7, and then times this binomial here. So this will be distributing. So just doing one at a time here, we've got negative 2 root 7 times root 3. So remember, there really is like a 1 sitting out front there. So this is negative 2 times 1 for our coefficient. Negative 2, and then root 7 times root 3 is root 21. Now let's just look at the next part of the rainbow. So now we've got root 2 times, and now I'm looking over here again. Think of this as like negative 2, right? We're like subtracting 2 here. So it's like negative 2 times negative 2. This is going to be positive. Negative times negative is positive. And then 4. And now I have root 7 times root 5. This would be root 35. Again, we want to be on guard here to maybe collect any like terms if it turns into like terms, or just simplify if we can. But there's no perfect squares that go into 21 or into 35, so we're done there. Okay, let's take a look at E. So again, these should look somewhat familiar to questions that you've done in Math 10. Maybe it looked more like, x plus 2 times x minus 3. And maybe you've heard this referred to as FOIL. Again, it's the distributive property, though really. It's like this first term times the second one. And then it's the second term times both of those, right? There's going to be 4 lines there. So again, yeah, you might have seen that as FOIL. So that was what we were doing with polynomials. But now we're going to be doing other radicals. So just same process, though. 3 times 7, and then it's going to be 3 times the other term. And then it's our second term here, going to be multiplied by both of those. So we're going to initially end up with 4 terms. That's what you should be expecting when we're done here. So 3 times 7 is 21. And now I'm following the next line here, right, that one. So that's going to be 3 times negative 2 is negative 6. And then, well, there's no root on this one, right? But I need to include this root 5. Root 5. All right, my pen's going a little haywire here. Okay, there you go. Now moving to the inside here. So root 5 times 7, and it's positive, right? They're like for both of them. There's no negative involved there at all, so it's going to be plus. And then you just have to write it again as 7 root 5. Those things don't go together. They're two different things. Now, root 5 times negative 2 root 5. There's really a 1 on there, you can imagine. So 1 times negative 2, this is negative 2. Now, root 5 times root 5. Let's think about what that is. Root 5, let's just hold on for a second on this one. This is an important step. So root 5 times root 5. All right, so if you like, some students like to do this. They'll say, okay, well, that is root 25. Okay? Totally true. That is root 25. You can follow the same rule. And the square root of 25 is 5. Do you see that we just ended up with the same number again? Right? It just is just 5. That'll always be the case when you multiply the square root of something times something else, or times itself. You can also think of it in these terms. You can also think of it as root 5, right, times root 5 is the same thing as saying root 5 squared. And then the squared and the square root just cancel with each other, and you end up with just 5. Okay, so keep an eye out for those. I'll be showing you as they show up again to remind you. But so root 5 times root 5 is just 5. But we need to multiply by it. So times 5. Yeah? So hopefully that made sense. Okay, so now we go through and we just simplify what we can. So you can see here we've got 21 and we've got, I don't want to write it all again just for simplicity, but this is really negative 10, right? So let's just go 21 minus 10. So my constant terms there is just 11. Okay, so we got 11. And then we actually have like terms this time, root 5 and root 5. So when we're adding radicals, we just add the coefficient. So negative 6 plus 7 is positive 1. So this is like plus 1 root 5. But you wouldn't usually leave the 1. You'd write this as 11 plus root 5. And it would have been just as fine if you would have wrote it as root 5 plus 11. It doesn't matter on the order on that. Okay, let's take a look at F. So first thing, I'm going to show you the mistake that usually happens on these questions. So when we're squaring all of it, is a student would do this quite often where they would just square this one and square this one and call it good. That's usually people's initial instinct, right? But remember what it means to square something. When you square something, you're multiplying it by itself again. So whenever you see these ones with a square in the top, you need to write it again. So it's got to be root 11 minus 2, and then it's squared, so it's got to be multiplied by itself. Minus 2. And you can see now that I have it written in this form that we're going to actually have 4 terms show up again initially. So that's different than if we would have just squared both of those, right? When we did that, we forgot about the middle terms that are going to show up. Okay, so here, let's look at this again. So let's keep going now. So we got root 11 times root 11. Remember what I was saying before, right? Root 11 times root 11 is just straight up 11. Because it's like root 11 squared is just 11. So nice and easy, right? Once you get the hang of that. Okay, and now root 11 times negative 2 is just negative 2 root 11. Nothing more you can do there. I end up with another one of those in the middle here. So negative 2. Come on, pen. Okay, I think I got her back working again. Yeah, negative 2 root 11. And then the outside. So now I'm just on the last one there. Negative 2 times negative 2 is positive 4. We'll collect our like terms. So with our constant terms here, we've got 11 plus 4 is 15. And then I'm going to collect my like terms. So negative 2 minus 2 is negative 4 or minus 4 root 11. Okay, so now on this one, it says solve the following area. So in the last lesson, we were finding the perimeter because we were just adding them all together. Now we're multiplying. So if you remember the area of a rectangle, so area is always length times width. And this time, instead of the length being, like a number and the width being a number, they're radicals. So same thing though, right? We're just going to have to go this one, times this one. Okay, so let's write that out. So it's going to be 2 plus root 27. And one thing I want to mention here is that we need to put this in brackets for this to work out properly. Don't just go multiply the next one. It has to be in brackets. And then times root 18 minus 3 root 6. Okay. So before we get going, actually, I can actually make these numbers a little bit nicer to work with. This 27, this 18. I actually recognize the 9 goes into both those numbers, so I can take things out. It'll just make it nicer to do my multiplication with. So I'm going to write this again. But I'm going to rewrite the 27 as 9 times 3. And I'm going to rewrite the 18 as 9 times 2. And then I'll take it out on the next step here. So we got 2 plus, that 9 gets to come out as a 3. So 3 root 3. And then 3 root 2 minus 3 root 6. I just did that just so the numbers were smaller. So look, okay, so I think we're good to go now. Let's distribute. So this is going to be 2 times 3 root 2. That is just going to be 6 root 2. And then moving to the outside, that's going to be 2 times negative 3, negative 6 root 6. And then on the inside here, we've got 3 root 3 times 3 root 2. That's going to be positive 9 root 6. And then just the last one here. So now we've got 3 times negative 3. This becomes negative 9. And then 3 times 6. It's going to be root 18. Yes. Okay. Okay. So now we would collect our like terms, but I just got another case where that 18 popped up. Right? Remember we were able to simplify that 18 down a little bit. So I'll do that on the next one. Let's combine these, just maybe one thing at a time. Combine those into a single term. So we've got 6 root 2. Negative 6 plus 9 is positive 3 root 6. Just collecting those like terms, right? Because those are the same. And then minus 9. And I'm going to rewrite the 18 here as 9 times 2. Because that 9 gets to come out. So we see that we've got 6 root 2 plus 3 root 6. And now I'm going to do this all in one move here. The 9 gets to come out as a 3 times the 9 that's already out there. So this becomes minus 27 root 2. And that was important because now I have like terms again. I've got the root 2 and I've got the root 2. So 6 minus 27 is going to be negative 21 root 2 plus 3 root 6. And there we go.